over the last 30 years in the video games industry, we've distilled the neurochemical recipe for driving learning and actually driving behavior change among any audience. Like, we have figured out how do you hit the perfect balance of reward and frustration, of challenge and skill, to literally maximize the release of certain neurochemicals in the brain at the right time to maximize neuroplasticity and behavior change. Use the neuroscience of video game design to accelerate the adoption curve in healthcare. It's, the biomechanical puzzle of spine surgery, or how to train someone's brain, how to interpret ultrasound. Like, that's the work that we were doing with NASA and SpaceX to train astronauts how to do ultrasound independently on deep space missions.
What if gaming could make doctors learn faster? Sam Glassenberg is the founder of LevelEx, the groundbreaking company using video games to train healthcare professionals. A game designer turned medtech innovator, Sam saw that the same mechanics that keep players engaged could revolutionize how surgeons and clinicians learn. LevelEx's games are used by hundreds of thousands of medical professionals worldwide, proving that play can be one of the most powerful tools in medicine. Welcome to Reinventing Capitalism, the podcast where I, Claudia Thomas, decode the success of for-profit impact businesses through the stories of their founders. Our goal is to inspire you towards a purpose-driven career, because life's too short for boring jobs and soul-crushing corporations. Quick note before we get back to the episode. Just give me 30 seconds of your time. Two things. The first is a huge thank you for listening and tuning into the show week after week. It means the world to me. And the second is that we are just getting started. If you enjoy what we do here, please join the 14% of people that listen to this podcast regularly and follow us on this app. I promise to do everything in my power to make this show as good as I can, now and into the future. Thank you. It seems like your life has two magnetic poles. One is medicine, and the other one is gaming.
True.
True. Okay, we're starting on the right foot. I guess my first question is, you grew up surrounded by doctors, but you decided to pursue gaming. Where did that curiosity for gaming come from?
By accident. I'm very lucky. I've had a lot of, as they say, happy accidents that have shaped the direction of my career. I did computer animation as a hobby in high school. Now this is the late 90s. Like, Toy Story came out in 1995, and by 1997, 1998, like, I was doing computer animation and making little fun animations for my friends and whatnot. Eventually, I built up enough of a portfolio of a reel that when I was in college, I submitted it. I wanted to work in feature film. I wanted to work at like Pixar or DreamWorks, one of those. So I applied. And I applied at Lucasfilm at ILM in the special effects division. And they offered me a job not at ILM, but at LucasArts in the video games division. And I was like, all right, let's try this out. And whoa. Like, once I got in there, I realized the problems and challenges of making video games were way more interesting than feature film. And so that kicked off my career.
So what was next? Like, where did you work? Where did you learn everything you know?
Well, let's see, I did undergrad at University of Illinois, computer engineering. Did grad at Stanford, computer science, focus on graphics. My in between, I went back and forth to school. So started out at LucasArts. I was hired as an animator. Like, literally, my job was to fly spaceships for Star Wars video games for the little cutscenes in between the levels. But I was the only engineer on the art team, so it was very lucky for me. I was an artist, I was hired as an artist, but I was an engineer. And so I'm surrounded by the most talented artists in the industry, like this Lucasfilm. And I quickly realized that no matter how much effort I put in, I'm never going to be as talented as they are. But I have this engineering background. So as the artists keep running into all these problems, we want to have a level that, where you fly around an asteroid, but their terrain tools didn't work on spheres. Like, there are all these crazy technical problems they couldn't solve. And I would come in and be like, wait, I can fix that. And then next thing you know, like, I am now no longer flying spaceships anymore, but I am making sure that technology does not get in the way of what artists want to achieve. And that set the stage for my career. So my next job, I was at Microsoft. I led the DirectX graphics team. So if you think about, like, my job was to build the Matrix, to figure out what video game graphics need to be able to do, 10 years from now, and shepherd the ecosystem in that direction. It's the core graphics technology behind PC, Windows, Xbox, all this stuff. So again, sort of this theme of, you have people that are visionary and want to create these amazing experiences and they want to create these universes. The hardware, the software can't do that yet. What needs to happen so that their vision can be realized? After that, was a hired CEO for a company that did games I pivoted it to make games for Hollywood movies. And then now I do video games for doctors.
You do. How did you realize that game design could be used to teach medicine?
Also by accident.
Tell us. Tell us
So,
more.
I've had this impactful career in the video games industry, but essentially that's made me the embarrassment of my family because I come from a long line of doctors. My grandfather was a famous doctor. My parents, everyone's doctors. I'm the idiot who didn't go to medical school. To show you how bad it got, in 2006, I accepted a technical Emmy on behalf of my team at Microsoft for pushing the cutting edge of video game graphics. It's not the TV Emmys, it's the technical Emmy. It's the same statue. That's me. I was younger then. That's Jensen Wang accepting his. Like, we were both much younger then. And so I call home to be like, hey, mom and dad, accepting an Emmy on behalf of my team for pushing the cutting edge of video game graphics. And my dad answers the phone. And without skipping a beat, he's an anesthesiologist. He goes, Sam, that's very nice. But in this family, we only recognize Nobel Prizes. He goes, you're not yet 30 years old. Stop wasting your time. Go to medical school. So this is the universe that I come from. So finally, a few years later, in 2012, he gave up. And he said, all right, Sam, you're too old to go to medical school. Please put all this gaming nonsense to good use. Make me a game to train my colleagues to do a fiber optic intubation. Tricky procedure, experienced anesthesiologists struggle with it. He goes, Sam, can you just make me a game that they can play like on their phones? I don't want to have to drag anyone to a training center. So I'm busy running like the biggest independent game studio in Hollywood. I go, sure, Dad. So I sit down for 3 weekends, throw together this like ugly little game, and I upload it to the App Store, and I don't think about it again because I have a day job. So 2 years later, my dad calls me. He goes, hey, Sam, how many people downloaded the thing? I go, Dad, I don't know how many of your friends downloaded your fiber optic laryngoscopy video game, but I can check for you. I look and I discover, unbeknownst to me, we have 100,000 doctors, nurses, and airway specialists who've been playing it.
So you had not checked for the past 2 years?
I put in like ilarynx@glassenberg.com as the email. I was sure nobody was going to download this.
Oh
it
my
was
God.
literally just to get my father off my back.
Okay.
And I'm like, and remember, I make games that are played by like tens of millions of people. So, but this in healthcare is unheard of, right? To get like, anesthesiologists and whatnot. So I Google it to try to understand what happened. And I discover, again, I had no idea, they've been doing efficacy studies at academic hospitals all over the world that showed that this crappy game I made for my father was drastically improving physician performance. So this was not some grand idea. Ooh, video games for doctors. Like it was like, okay, wait a minute. What if it wasn't just me, right? What if we did this for real? What if we took the top video game developers, designers, artists who've worked on everything from, Mortal Kombat to Diner Dash, and you team them up with hundreds of physician advisors across every major therapeutic area in medicine to, as we say, advance the practice of medicine through play. All right, to use the technology, but more important than technology, use the neuroscience of video game design to accelerate the adoption curve in healthcare. And so that's what we do. We have like, it's now been split into 2 companies, literally millions of medical professionals playing. Between the companies, they're working with most of the top 50 life science and med device companies, working with NASA. Doctors are earning CME credit toward renewing their medical licenses from playing video games. Like, it's crazy stuff.
Wow.
Fun.
I can't believe that all of this started from like the coincidence that your dad asked you to build the game when you didn't even want to build it.
Yeah, look, this is, there's a little bit of like creating opportunity here. Like, there's a term for that, but like, when Like I tinker. The whole reason I started doing this was, I like in high school, I was doing animation as a hobby, but like got really into it, and making games, like all of these things, people ask me to do things. I come up with ideas, sit down and you start making things. Most of them don't turn into anything, but sometimes, that you can, serendipity, or you're able to create, something, and the thing you thought
Yeah,
wasn't going to work ends up being a huge success.
for sure. What's the range of topics that you teach, or which types of doctors
Oh
do you
my
train?
God. Everything. And we're just scratching the surface.
Oh wow.
So, I mean, where do I even begin? We've got so there's basically two studios now. So one makes clinical gameplay. So it's everything from how to different mechanisms of action and disease, how do different drugs work, understanding how to diagnose skin disease on skin of color, or different rare conditions, how to diagnose the puzzle game of diagnosing rare disease, how to manage complex patients. On the surgical side, it's the biomechanical puzzle of spine surgery, or how to train someone's brain, how to interpret ultrasound. Like that's the work that we were doing with NASA and SpaceX, to train astronauts how to do ultrasound independently on deep space missions, because that's your only imaging modality. So
Mhm.
like every major therapeutic area in medicine now, like I said, working with most of the big life science and med device companies, and now only now starting to actually create also some games for patients. But it's, like I said, just we're
Yeah.
still addressing 1% of the problems, if that.
How many users do you currently have?
Oh, across all the different I mean, a couple million. I mean, more than that, but the only users we actually care about are the medical professionals.
Yeah.
So while there are even more millions of people who play our games, the ones that we care about are, doctors, nurses, people that are actively practicing medicine.
Yeah.
The one exception, when we make games for patients, then we want sort of patients and caregivers, but those projects just began.
So, wait, why would non-doctors play your games? It seems very visceral and like very within the medicine realm.
I don't know. Why would somebody want to do a colonoscopy for fun? Maybe it's intellectual curiosity. Maybe it's because they're considering a career in medicine. I don't know.
But what's the percentage? What's the ratio between non-doctors versus doctors that use the game?
So it depends, because some of our games are deployed like via a cloud gaming platform. So we just literally, send it straight to the doctors. There, it's all medical professionals. If you open up the App Store, you'll find 5 or 6 games from LevelEx. Those games are just freely available to everybody. Those, probably a third of the installs are medical professionals.
Mhm.
So say a couple million there, and then the rest are, muggles, as we say. Like
Yeah,
we don't count them toward our metrics, because, we're not, like, my goal is not to teach you how to be a doctor.
I
My
hope
goal
not.
yeah, assume you already are one, and then we're going to present you with 5 lifetimes worth
Yeah.
of rare, difficult, unforeseen, cases of rare disease diagnosis, colonoscopies, complex heart surgeries, whatever you're looking for.
So these games, it looks to me that it's quite complex, as in like it's not a simple game. Like there's a lot of information, research put into these games. What's the process to ensure that they're clinically sound, and that all doctors can trust the game?
So well, first I should say it is very complicated to make them. However, the design point is such that we want the games to actually be as simple as possible to play.
Yeah,
So we want you to be able to play the game and to be totally obvious what you're supposed to do next. We have games where you're making clinical decisions, or you're just, swiping cards, or, you're learning how to manage a ventilator by tapping one button. We're trying to keep it as simple as possible.
yeah.
However, obviously designing it for medical accuracy is very tricky. So for that, we actually have a full-time medical team. So
Okay.
just like any video game studio would have an engineering team, design team, art team, we have a dedicated medical team of biomedical engineers and doctors, full-time. That's enough. That's still not enough. We also have a stable of hundreds of physician advisors and contributors who will review the content, give us ideas, give us feedback. Everything that we do goes through a peer review. And then on top of it, for games that are getting CME accredited, so doctors can earn AMA Category 1 credit for renewing their license, that goes through another level of review to validate that it also, closes educational gaps. And
Yeah.
anything that we do with industry goes through what's called a medical legal regulatory review to make sure that everything we're doing abides by FDA guidelines. So, for
Okay.
example, you're playing games with clinical study data, or you're using a medical device. Like in the game, we can't let you use it for an off-label use.
Yeah. Yeah. Okay. So you also mentioned earlier that even if they are medical games, you've used the neuroscience behind gaming. Can you
Yes.
talk a little bit about that? I would love to understand how that actually works.
So this is all of the cool technology that you see of the blood and all of this is in service of something way more important. And that is the neuroscience of video game design. So essentially what's happened is over the last 30 years in the video games industry, we've distilled the neurochemical recipe for driving learning and actually driving behavior change among any audience. Like we have figured out how do you hit the perfect balance of reward and frustration, of challenge and skill to literally maximize the release of certain neurochemicals in the brain at the right time to maximize neuroplasticity and behavior change. This isn't just talk. Like every video game is doing this. You've played Angry Birds?
Yeah.
Yeah. Okay. Good. Good. Why? Because everyone's played Angry Birds. Okay. Why is Angry Birds so addictive? Why you'll hop on an airplane, you'll still see people playing this game 10 years later. Why is that? Because we've evolved to play Angry Birds. What do I mean by that? Think back to the first time you played. What happened? Angry Bird hops in the slingshot. You aim it at the Tower of Pigs. You fire. And what happened the first time? You remember?
I can't.
You missed. You missed. And what happens when you miss? The pigs laugh at you. Why? Why? This makes you frustrated. Second bird hops in. You aim a little better, but you still miss. And the pig laughs at you again. And you get more frustrated. But now I'm starting to get the hang of this. Third bird hops in. You aim a little better. You fire. And it's glorious. There's explosions and animations. And the pigs go flying. And the music changes. Why? All of this was deliberately designed to trigger a dopamine release in your brain that physically reinforced those neural connections that you used on that last successful fire. That is why an hour later, you're firing that bird between two narrow obstacles at 50 meters, and why 80 hours later, you're still playing the game. Now, this whole neuromechanic, we didn't invent this in the games industry. It's existed in the mammalian neuron for tens of millions of years. This is, for example, how our ancestors learned how to throw a spear, right? Same thing, parabolic flight, right? What would happen? You get miss, frustration, hit, dopamine. All right, what are the neural connections we just used on that last throw? We want to use those again, so make those thicker. That's how you learn. And so in video games, we can use this to train your brain to develop a mental model of parabolic flight, but we can also use the same techniques to train your brain how to use deductive reasoning or reductive reasoning to diagnose rare disease, how to manage a ventilator, how to manage type 1 diabetes, how to manage a complex patient. But again, it's all about hitting that right balance and designing it correctly. If you do that, you can really move the needle.
Wow. So interesting when you understand the intricacies of what makes you addicted to something.
Oh yeah, this can be used either way, right? You can use all of this. This is the basis of the gambling industry, right? Is dopamine, endorphins, whatever. You can use it for that, or you can use this to train doctors or anyone, right? Substantially faster. Or even look like Pokemon Go, right? They use this to get, tens of millions of people, hundreds of millions worldwide, who otherwise would never get off the couch up and walking for miles. So there's all sorts of behavior change that you can drive with this and social good that you can achieve, if like anything else, it's powerful. You can use it for good or evil.
Absolutely. Absolutely. So thinking more about the business aspect of things, what's the business model for a game like this?
So, well, for Angry Birds is Angry Birds. For medical
No,
games,
yeah,
yeah,
for a
those
medical
for medical
game.
games. So the way we do it for medical games is, um, it's very important for me that this stuff be free to everybody. So the way we do it, it's very, we didn't invent this business model, but it's sponsorship based.
Okay.
So just like you go to a medical conference and you go attend sessions, you earn CME credit. What's actually funding the conference? It's not your pittance of a registration fee. It's the expo hall, right? It's industry. So what happens is the content's available for free to doctors. Interspersed in the content in the game, you can find sponsored content. So, for example, like on our uh, cardiology game, you play a bunch of levels. Then, if you want, you can play a clearly sponsored game where you play the same levels but with, Philips's tools, or you learn about the new heart failure guidelines sponsored by Novartis because their drug is indicated. So, like these are all. So basically, what's happening is you go into these games and there's sponsored content from either life science companies or med device companies, and that funds everything.
So it's mostly advertisement.
Yes, almost entirely. There's a little bit of grant funding from, NASA and that sort of thing, but almost all of
Yeah.
it is industry funded.
Okay. And your users are doctors, of course, but do you target them directly, or do you also sell or like grow the game through partnerships or selling B2B?
We do mostly direct now, especially because now that LevelEx has been acquired, our acquirers have big audiences. BrainLab acquired our med device business, and they're like one of the largest med device companies in Europe.
Mm-hmm.
And then Relevate Health acquired our life sciences business, and you know, they're a healthcare marketing company marketing to 80-90% of US physicians.
Yeah.
Uh, but we do partnerships. We have done partnerships with major medical societies. We do our own promotion of our games on occasion. For example, we just launched a game in type 1 diabetes. We're partnered with the two largest type 1 diabetes organizations, Breakthrough T1D and Beyond Type 1. So, just like any game, you're going to distribute it through multiple means and through different partnerships.
Yeah. You mentioned the two companies that acquired LevelEx. How long after you founded the company were you acquired?
So we were acquired the first time 5 years in
Okay.
by BrainLab. They were one of our customers, and then a few years after that, we basically separated. We did as we say in biology terms, we did a mitosis into two studios
Mm-hmm.
because LevelEx had always sort of been a little bit of a hybrid. We had sort of half our business was in the surgical side and half in med device, and half our business was, or almost half our business was life sciences and clinical. And so
Mm-hmm.
basically we sort of separated into two studios, and Relevate acquired the clinical studio from BrainLab.
Hi, can I ask you a quick favor? Every week, we dive into the stories of founders that do more than just make money. Our mission is to prove that a career in impact can be both purposeful and financially sustainable. If you believe in creating meaningful work, share today's episode with one friend who's ready to make a difference. It would mean a great deal to me. Your support is what keeps this show alive and growing. Thank you.
And how did you reason the acquisition? Because it seems like 5 years, it's kind of soonish after you founded the company. For other founders listening in today, how did you reason selling your company?
It was great timing. Like we had the company was growing quickly, and BrainLab actually came in as they were one of our customers. Then they became one of our investors, and then they saw the impact that LevelEx was able to have on their own products, and they have a much broader vision of expanding beyond neurosurgery into all sorts of different therapeutic areas. And the biggest obstacle to that growth was not technology in terms of the devices themselves. It was behavior change. Can you get people to adopt new modalities of doing
Mm-hmm.
surgery? And we showed with LevelEx you could. And so it was just a great opportunity for us to scale. But even then, even as part of the acquisition, it wasn't total because we kept growing the business, and we also kept growing an additional business sort of in an entrepreneurial way, which was this life sciences business that had nothing to do with BrainLab because their customers were life science companies. But that other business, right, still grew innovated, created more value, and then eventually had its own exit.
Yeah.
So I guess you could say it was an acquisition, but I got all the benefits of getting acquired and all the benefits of being able to continue to grow a company, but I didn't have to run around raising
Money.
multiple rounds of VC money, and I could actually just spend my time growing my business.
Yeah, yeah, absolutely. So you've said two words, which are impact and behavior change. I assume that the behavior change is the impact that your company has. How do you really track that?
Oh, all sorts of ways. I mean, literally, a lot of it is actually looking in the EHR. So,
What is EHR? Sorry.
sorry, electronic health record.
Okay.
So in the United States, there's like aggregated healthcare, like these data sets are available and there are companies that manage them. So we actually are able to measure doctors who play our games versus doctors who don't. How does that affect their diagnostic, treatment, and prescribing behavior? So you can see that at scale. We also, on top of that, run more focused studies where we'll literally measure, we'll take a cohort and we'll literally just measure, what is their knowledge retention and so forth. So for example, like often what we'll do, like the EHR data doesn't tell us things like doctor's age. So what we'll do is we'll use the EHR data and we will see, all right, we've been able to change diagnostic behavior, improve treatment behavior, so forth. But sometimes we'll do like a focus study, for example, like this one we published recently, where we wanted to just focus on older doctors and say, all right, once you control for existing knowledge, how effective are video games at helping them understand, how to diagnose disease? This is dermatology, so it's like how to diagnose skin disease. And we found that it was really interesting. Like if everyone assumes that games are for the younger doctors,
Yeah.
but when you take a doctor whose average age of 45 has been in practice 15 years, sees 150 patients a week, how does their behavior change? How is their knowledge retained better than other ways of training? And games were the most effective. And we were able to see it's not just like they're just remembering facts. You present them, 6 weeks or months later with clinical scenarios that use the information that they would have needed, and you see what their performance would be in those.
Yeah.
So it's everything from a combination of sort of like presenting them clinical scenarios and then actually observing what they do.
Yeah.
And of course, they've been doing, other academic institutions continue to do, efficacy studies just like they did without me knowing it 15 years ago.
Yeah, this might be a stupid question, but I'm thinking you're obviously speaking about how you're tracking what doctors learn and how they digest your content. Is it a way to track like patient history? So like the impact that learning has on patients?
We have not done that yet. Because usually what we're doing is we are taking clinically validated information and disseminating it, right? So FDA approved studies have demonstrated this drug is more effective than this drug. The American Heart Association has published new guidelines for managing heart failure, right? They're published, they're peer reviewed, they're validated that this results in better patient outcomes. The problem is in healthcare, just because you have a new guideline doesn't mean that people follow it. It's usually 10 years before, that becomes what we call sort of like the standard of care, because doctors, like, you give me like a complex flow chart, you expect me to memorize it? Like, what? No,
Yeah.
doctors learn through play, right? They learn through trial and like, oh, whoops, shouldn't have done that. Okay, stress hormone, like, all right, don't do that again. Like, oh, I got it right this time. Oh, great, dopamine, good patient outcome.
Yeah.
So great. So what we're able to do is just compress that. So we take stuff that's already been validated and then, and demonstrated to improve patient outcomes, and then we disseminate that. Now that we're starting to actually make some games for patients, we're exploring doing some efficacy studies to see, games that train patients how to do things. Are we able to achieve better outcomes? But those are currently in development and in flight. We haven't published anything yet.
Okay. For what you said, it seems like memorization remains the dominant mode of medical education. What's wrong with that model on how doctors are trained?
Look, doctors are very smart and they are way better at memorization than I am. But fundamentally, the challenges of medicine are not related to rote memorization. Understanding how to, diagnose skin disease on skin of color. Well, let's look at one example. Let's look at let's look at skin of color, for example.
Mm-hmm.
So this is Fitzpatrick. This is like the famous, most commonly used textbook for skin disease.
Okay.
See the problem?
A lot of text, a lot of
No,
images.
look at the
Oh,
images. Oh, the
oh
images.
yeah.
They're all the same skin tones. So we're this is a major. So like dermatologists saying, Sam, this is a major problem. Um, and you can't just look at this and memorize it and then know how to diagnose skin disease. The only way to learn how to diagnose skin disease, well, right now is if a doctor sees a lot of patients of a certain skin tone, she is going to get much better at
Mm-hmm.
diagnosing, not even just diagnosing disease, but understanding like, is this responding well to medication? And so we went online to try to find like, all right, are there repositories of images of all these diseases and different body parts? And there aren't on different skin tones. So what we ended up doing is using video game technology to be able to create systems that allow us to generate any skin disease
Mm-hmm.
on any body part at any severity on skin of any color. So none of these images are real, right? This is, um, these are all computer generated.
Mm-hmm.
But the important thing, because they manifest different ways on different skin tones. But the important thing is like this is not rote memorization. This is brain training, right? Like this is how do you, a description of plaque psoriasis is not going to help you memorize. Like, memorization is not helpful here,
Yeah.
right? It's brain training. It's training not just looking at it visually, but sort of like understanding disease progression and things like that. And the same goes for, diagnosing disease. That's not like memorizing, these symptoms mean this. Like, that's not how it works. It's a reductive reasoning puzzle. How do
Mm-hmm.
you train your brain? What test eliminates what? So it's really, it's way more sophisticated than that. And that's the part that doctors learn, but they learn through, see one, do one, teach one. Like they learn on live patients.
Yeah.
Not because they want to, but because they're not given any better choice.
Yeah. So what's the goal? Is it the goal to substitute textbooks, or like how are you integrating LevelEx with the current education model?
So we don't really do much in graduate education. So we have like I think half the medical students in the US have one of our games on their phones, but we don't build content for them.
Okay.
It's just our business model doesn't really support that. Industry is not interested in advertising to medical students. Someone else needs to go solve that problem. But what we focus on is just how do you keep doctors up to speed? They're going to be practicing for 40 some years. Throughout their practice, medicine is going to continue to accelerate. And how do you keep them up to speed such that when new treatments come out, you accelerate the adoption of those treatments? So instead of you having to wait 10 or 15 years for it to be broadly adopted, it's broadly adopted quickly, and doctors are able to use it effectively and correctly to get,
Yeah.
that's the goal.
Yeah. Let's get into speaking about the elephant in the room, which is AI. How do you see AI reshaping what doctors need to know versus maybe how they need to think, considering that, as you said, memorization, it's not like the North Star of medicine anymore?
So, as far as what it means for, I mean, I know that it's going to be amazingly transformational for medicine in general in terms of getting better outcomes for patients.
Mm-hmm.
We're actually at LevelEx using a lot of AI technology to create our content and create our games, just like the entire games industry has been wholeheartedly embracing AI.
Mm-hmm.
As far as for doctors, like I don't, what's going to happen is just like with games, they're going to move up the stack. So, the example, let me pull up an example from games. So in, the games industry, basically, like I said, we've wholeheartedly embraced generative AI for everything. Well, not yet everything, but we're all over it.
Yeah.
Why is that? Well, because every 5 years in the video games industry, we're able to deliver games that are an order of magnitude more realistic. So like, this is a eye and a
Yeah.
buttock.
Yeah.
Like, I also actually like to contrast this to state of the art medical education, but we'll do that in a minute. But you can't create this using tools from 5 years ago, or
Yeah.
even, yeah. So if you're going to do it, you need, like in the video games industry, every 5 years, an artist is completely like, if you're an artist and you're doing something the same way you were doing it 5 years ago, there's something wrong with you.
Yeah.
Right. So every 5 years, you need to move up the stack, right? Going from, drawing things by hand to like modeling with virtual clay to literally, building cities out of math. Like the video games industry, like artists, designers, engineers are constantly moving up, right? Whatever you were doing 5 years ago is now automated. Now you're, because you have to deliver, you have to rebuild the entire city of Chicago or, create thousands of characters. Like you're not gonna be able to do that by hand anymore. You have to use tools. And so for us, AI is just the next generation of those tools.
Mm-hmm.
And so we've been embracing it wholeheartedly. I think the same thing's gonna happen to medicine, where you're gonna be doing a lot less, there's gonna be a lot less sort of, definitely the first thing is just data entry. My God. Like what technology has done to medicine over the last 20 years is a disaster of basically turning doctors into, glorified, I don't know, data entry. I don't know what the term is. Just sitting there, like spending hours and hours and hours filling in EHRs. Like that's done now. Now you can just have a microphone on the table, you talk to the patient, you explain what you're doing, and then the EHR gets filled in and you click a button. Like that's the way it should be. And it's just going to be that way for diagnosis and treatment and other things. You already start seeing robotic assisted surgery. You're going to be doing a lot more orchestration and a lot less, manual doing things. And over time, like that's going to mean that, the top the top doctors are more productive and the gap between the expert and the novice, can be filled. That gap closed with, again, we're closing that gap with game technology, but it'll also be closed with AI.
Yeah. AI is learning faster than any med student. Well, actually, let me give you an example. This winter, I was skiing with some friends, and one of them fell and broke his shoulder. And the doctor who attended him used ChatGPT to consult him. Like literally, he was putting like the information that my friend was telling him, and putting it into ChatGPT, and he was getting the answers. Like I was like really surprised about it, because obviously, like it seems like AI could replace the doctor, but then like to which extent do you trust it with, I don't want to say a life or death decision, but an important decision as it is to break your shoulder?
I mean, would you trust how much would you trust a doctor who is 6 months in practice, right? Like it's not homogeneous, right? Like throughout healthcare you have underserved communities, you have you have doctors early in training that don't have a lot of practice, so like this becomes a tool like anything else. Can you trust it? Well, I mean, just like can you trust any medical device, or can you trust any, obviously it's not something that you can just like blanket say yes or no. It's a case by case basis. All right, what's going in here? How well trained is it? Like we have methods to validate the effectiveness of different things. All right, great. Like let's, like they're doing now, like, all right, let's look at, let's build an AI that's trained to diagnose this. How effective is it relative to practicing radiologists? How is it relative to the average radiologist? How good is it relative to the expert? This is going to tell us where we should use it and who should use it and when.
Yeah. Okay. Good answer. So essentially, like we have to wait to have models that are exclusively trained on medical data and on performing specific tasks to understand how they can become.
Yeah, exactly. I mean, ChatGPT is still great. It's still trained on this massive bolus of medical information that no doctor could memorize. So use it, but obviously it has a tendency to hallucinate. So be careful.
Yeah. Yeah.
Especially ChatGPT 4.0. I wouldn't use that one.
Okay.
But there are versions that are better, and you can always, and there are AIs now that show their work, so you can look at all the references, and if something doesn't feel right, you can click the link and open up the article and read the study.
Yeah. In this podcast, we talk a lot about the meaning of work and having meaning at work is one of the variables that help you be more engaged and satisfied with what you do. But obviously, it's not everything. I've heard you say that building LevelEx gave you a sense of alignment that maybe you didn't have before. What changed for you as a leader when you found your why, or when your why became clearer?
This is not so let me actually clarify something. Like, it's not like all of a sudden LevelX, like I found meaning in life when I started with LevelX. Like, I think that, look, I do not understand how people wake up and spend the majority of their waking hours doing something they don't find fulfilling or meaningful. But, you know, that can take many forms. So for me, like creating entertainment for a billion people and telling stories and creating universes, that was very fulfilling early in my career.
Mm-hmm.
And then quickly realizing there were people that were way more talented than me and could do a better job of it, but were being blocked by technology, and I could uniquely help them because I've worked as an artist and engineer. That was also fulfilling. How do I make sure technology does not get in the way of an artist's creative vision is a very fulfilling undertaking,
Mm-hmm.
and then scaling that up, right? And so we say in the video games industry, people index high on the fulfillment scale, meaning most people in the industry, they're super talented. They could go get a job writing bank software, making 3 times as much money. But again, like, they wake up in the morning and they need to know that what they're doing is, having positive impact. Now, so the reason it's important to say is, like, we recruit a lot of people from the games industry, and people will say, like, "Oh, Sam, isn't it great that you finally give them meaning in their life?" And it's like, wait a minute, no, like, making games is a creative, fulfilling endeavor. However, the people that we tend to hire are people who said, "Look, I've done this now.
Mm-hmm.
Like, I've already shipped 3 Call of Duties. I built games that have been played by half a billion people. I've done this, this, and that. Okay, how do I now apply my skills in something new that can also provide additional value to society?"
Mm-hmm.
And that's where we get some of our top people, because they're like, "All right, I've already done this. Now, oh wow, this is a great way to apply my skills in game design or game technology, but do it in a way that, helps train doctors how to do better ultrasounds, or, diagnose skin disease, or, help people learn how to manage type 1 diabetes."
Yeah. No, absolutely. No, I agree, and definitely it depends on the stage, on the stage of your life that you're in. And as I said, I already prefaced this by saying that, like, meaning at work is not everything, but definitely I agree with you that, like, you cannot wake up every morning, or I would encourage people to not wake up every morning thinking that they hate their jobs or that their jobs are meaningless. And I think that having a purpose like this, where you work in gaming and health, or any of the companies that I interview here, I think it does get you a little bit closer to feeling that what you're doing, it's to add some more value to society.
I agree. I agree. And, like, for real, not the people
Yeah,
who
exactly.
make value for this. I'm doing a
Like,
blockchain fintech, blah, blah, blah. It's like, I don't,
yeah.
because the problem is most companies are not financially successful. Like, most startups don't make it to exit. So at least if you're, if let's say your startup doesn't make it to exit, but, you're like, "Look, we built things, we impacted people, we had positive impact on society." Like, great. If your whole reason you're doing this is making money, then go to the casino,
Yeah,
right?
yeah,
Get it over with faster.
yeah, for sure. Um, okay, so I want to end by looking ahead into the future. Um, how do you envision game-based learning playing a role in closing the medical gaps that we see in the world right now?
There are so many gaps now. I mean, I think probably the classic example, like one example I'll give you, is ultrasound. So the work that we've been doing with NASA, let me see if I can pull that up. So the work we've been doing with NASA has been because, has been actually funded largely by the Mars mission. Why is that? Because one of the challenges they're going to have with the Mars mission is it's a 9-month each way trip, and you're in a resource constrained environment. So, one of the astronauts grabs her chest and rolls over in microgravity. Like, what are you going to do? There is no CT scan. Like, the closest CT scan or MRI is a billion miles away. And so, and the experts are, far away. Like, there's no CT scan. The closest like it's a 20-minute round trip for the speed of light. So even though they have experts on the ground in Houston that can like read an ultrasound reading from the ISS, if you're en route to the Mars mission, you can't have him, like, it's too far away. You just can't get a response. You're remote. And so how do you deal with that? Well, you have, for example, ultrasound, which, you can have like a handheld device, costs like $1,000, plugs into your phone, very lightweight. But the problem is, I don't know if you've ever seen ultrasound, it's very difficult to interpret. But if you can interpret it, like, you can see inside the body, and there's all sorts of things that you can measure and detect and diagnose with and treat with ultrasound. So for space, there's all sorts of reasons why they need this, but all over the earth, you see this pattern of it's a resource constrained environment. Somebody doesn't have access to a CT scanner or an MRI. Maybe they can't afford it. Maybe they're too far away. Maybe right. But if we could literally just arm nurses in the field with handheld ultrasound devices that plug into their phones, we would, like, the quality of care would raise worldwide.
Yeah.
Right. Whether you're in the field in Ukraine or whether you're in Africa, but what's preventing that? What's preventing that is, well, interpreting ultrasound is really difficult. Like, every parent who's ever gone to the OB has had that first experience of like, oh, congratulations, it's you go, it's a girl. They go, it's a boy, because nobody can read this stuff.
Yeah.
And so how do you train somebody's brain to do that? Like, all right, so the stuff we did for NASA is, puzzle games that train your brain how to interpret ultrasound. If you can do that, right? If you can train ultrasound at scale, it's not a matter of cost, right? We can deliver these devices for $1,000 or $2,000 to everybody. The limitation is training.
Yeah.
So if we can close the gap on training immediately, like, a pregnant woman in sub-Saharan Africa, the quality of her care is going to shoot up like crazy, because now you can train people. Now at scale, she now has access to these imaging modalities. So this is just one of thousands of examples where if you can train people efficiently and at scale, you can reduce racial disparities in healthcare. You can reduce economic disparities in healthcare. We already went through the skin of color one. Like, there's endless problems to solve, and they're highly solvable with solutions that already exist in the games industry.
So what's preventing these games to reach doctors in the global south, for example?
Funding.
Mostly funding.
It's like getting you go build it for NASA. You need to actually, NASA invests the millions of dollars to create the simulator. Okay, great. Now you need to find, NGO partners and others that can grant fund, getting this deployed in sub-Saharan Africa. But the beauty is the big problem is solved.
Yeah.
Which is, how do you simulate this stuff? Once that's solved, deployment is easy. And that's why for things like dermatology, like, now it's available for free. People use it worldwide.
Yeah.
So, like, we showed the skin examples, that's already sponsored by industry, available worldwide, and anybody can just, go ahead and play the game. So no matter where you are.
Yeah, it feels so unfair that, as you said, like, the most difficult part, it's building the game, and now it's a matter of distributing it. So it feels unfair that everything it's built, but it doesn't reach, like, the people that need it the most.
That's been the case for healthcare since the beginning. But the nice thing, that's the mission, right? That's the quest, is keep cutting those costs, keep making it more available, keep reducing the barrier to entry. No, you do not need a multi-million-dollar simulation center anymore. All you need is a cell phone that you have already.
Yeah, exactly. Last question. Where do you see, or where is LevelEx going in the next 5 to 10 years? Like, what's your goal with the company?
So our mission is to advance the practice of medicine through play, and our vision, right? So what's the vision? Where do we go? Is games are just broadly accepted as a fundamental force accelerating the adoption curve in healthcare. What do we mean by that? So, 5 years ago, you said, we're from LevelEx. We make video games for doctors. People raise an eyebrow, like, what's a video game for doctors? Now you say, oh, we're from LevelEx. We make video games for doctors. People go, oh, yeah, I've heard about that. Or I've played such and such. That's cool. 5 years from now, you go, we make video games for doctors. And they go, yeah, of course. When did we not have video? Isn't that always been a thing? When did we not have video games for doctors? That's where we want to get to. This idea that, today you have a new device, a new technique, a new guideline, and you want to disseminate it, and you go, today, what are your tools? What are your forces? I can publish a paper. I can give a presentation. Maybe I make a video. But what you really need to do in a lot of cases is you go, you know what? You really need to play with this. Like when you get a new phone, you don't read a manual. These don't even come with manuals anymore. You go, oh, I got to play with this. Okay. So what's going to happen is whether you're a device company or you're a surgeon who comes up with a new technique, you're going to go, you know what? People really need to play with this. They really need a mental model for this. We need a game. And just developing a game just becomes commonplace for new techniques and new devices and new treatments throughout medicine. Then we've succeeded. Then we've succeeded. And the apex achievement in video games is not creating a successful game. All of us at LevelEx have done that many times over in our careers. The apex achievement is genre creation. Can you expand the relevance of games? And so that's what we're doing here. We're creating a new genre of medical games. And my hope is that we will not be the only ones. That one of the characteristics of a genre is you have a bunch of players in the market. There are way too many problems for LevelEx to solve, and I'm looking forward to more companies sprouting up that will do this and have a whole ecosystem. So in 5-10 years, you have lots of companies doing this, not just in medicine but elsewhere, solving all sorts of problems. And doctors are like, "Oh yeah, games that's how we learn now. We didn't learn this way before. I don't remember." It was long.
Yeah. Okay, so it seems that the industry is quite new. So you are one of the few players in the space. Is that it? Yeah.
Yeah, there's always been sort of medical simulation, but that's not games. They're not all the stuff we were talking about with dopamine and challenge and puzzles. That's all new. That's all new. They've done the usual sort of thing you expect of step by step. Here's how you do the procedure. There's no challenge. There's no, reward. That's what we've added.
Yeah. Well, Sam, thank you so much for jumping on the show. I really love what you're doing. It's very innovative. I can see why people love it, even non-doctors. It's a very easy and digestible way of learning about a new topic. And I do hope that this good work that you're doing is distributed across the globe and available to everyone that needs it the most. Because it's much, much needed. So thank you.
Thank you so much for having me.